All right, let's get started. Today we'll talk about object-oriented programming in R. This is we're going to continue on. So on Wednesday we talked about S3, and S3 was kind of the ad hoc informal system. You just take an object, whatever it is, and then you just say class that object, and you can set it to something else. The big difference between S3 as a object-oriented system versus other systems is that the methods belong to functions. Okay. All right. S4 is similar to S3, but it adds a little bit of formality to it. It's the methods still belong to functions, not to the classes. But the key difference here is that with S4, classes have formal definitions which describe their fields and inheritance. Okay, and then method dispatch can be based on multiple arguments to a generic function, and we use a special operator, the @ sign, for extracting slots or fields from an S4 object. So it says all S4 related code is in the methods package, and it's always available when you're using R interactively, but if you ever do things via batch mode or something, it's probably a good idea to put in library methods. Okay, so how can we tell if something is S4? Well, we just run this function, is it S4? Okay. If you type in str ask for the structure, it's going to say that it is a formal object. Okay. You can also load up prior and use otype, and that will say S4. But there is kind of a native function that says if it's S4 or not. Versus with S3, you had to kind of roundabout say, is it an object and is it S4? And if it was an S4, then it was an S3 object. Okay. There's no S4 classes in the base stats package. Okay, so base stats, everything there is S3. If you want S4, you either have to create them yourself, or you got to load up a little bit more complicated library. So there's the stats4 package, which creates an S4 class when you do maximum likelihood estimation. So when you do MLE with the stats4 package, it'll be an S4 class. So, for example, we can load up. This is, if you type in example MLE, it'll list off a bunch of code. But here we're just going to look at 3 particular lines. We just create a vector values for y. We create a function on lambda for the log likelihood here. Okay, and all that function does is it returns the negative sum of negative log sum of these Poisson values. What's the Poisson density given a particular lambda for these different things. Okay, right, because if you add the sum of the log likelihoods, that's like the product of the likelihood. Okay, so anyway, we're gonna just do create a maximum likelihood estimation based on this. Okay, and if you're not familiar with all of this, don't worry. This is just to illustrate that S4 objects exist. Okay, so we create a MLE object, and we're going to store the output of MLE into fit. Okay, and then so if we ask questions about fit, we say, is it an S4 object? It'll say true. If we use the function otype from prior, it will say that fit object, the result of this MLE function, is S4. Okay. Here, let me come over here. So fit itself is, we can see that fit is formal class MLE. All right, I can also ask, what is the structure of fit? And it will say formal class MLE with 9 slots. And let me zoom in for you. So the structure of fit, it's a formal class with 9 slots, and notice that instead of dollar signs, we've got the @ sign to indicate this is how we pull out the values in those slots. We can also ask if other things. So, you know, it says is knobs, okay? So what is knobs? Knobs is a function, but it is an S4 generic function. So we can say, is it S4? And we can ask knobs, is S4 the number, n obs is number of observations. It's a function created under the S4 system, and so if we say, is it S4, it's true. Whereas if we say, is S4 just a different function like standard deviation, that's not going to return true there. Standard deviation is just a regular old function here, right? So S4 is so nobs is a S4 generic. You can also just, if you want to use f-type from prior, oops, not S4, it will say it is an S4, but it's also a generic type function. Okay. So there is also a special version of the knobs function, or number of observations function, which is the method for the MLE object. Okay, and so we have, if we say, you know, method from call, this is a way to get the method knobs fit. Okay, so remember, a generic function is just the function, so you don't have to specify which specific method you want, right? Because with the generic, it has all of these methods associated with the function, and there's something that looks at the object, figures out what class of object it is, and it pulls the correct associated method. So in this case, if I do knobs number of observations fit, it's going to see that fit is an MLE object, and it's going to run the n observations function method that is appropriate for fit, okay, and it returns 11. There's another function that says method from call, and this will tell us which method is being used when this thing is running. Does that make sense? Okay, so when I say method from call, it's going to tell me when you run the n observation function on this fit object, the method that's being drawn is this thing, and it's kind of hard to tell exactly what's going on, but it's saying, you know, the target and this defined is for the MLE object. Okay, and so we can say, if we store this output, this method definition, into MLE underscore knobs, okay, knobs, we can just say this itself is an S4 object. Okay, the method is an observer, and then if we ask prior what is the type of function it is, oops, not MLE type, it will say it's an S4 function, but it's a method, versus when we just called it on nobs itself, it said it's a generic. Okay, so generic function is kind of the thing that you want to use, print nobs, whatever it is, and then the method is the special version of that function that applies depending on which class of object you give it. Okay, and so these are S4 generics and S4 methods. Okay, so it's different from S3, where you just kind of have print dot, you know, lm, print dot something else. So S3 was very informal, but it worked. You just have the function name dot the class, and that's the method that applies for that specific thing. Whereas with S4, it just gets more formal. Okay, and there's a function called is, and it will tell you, when you look at is for fit, it will tell you what class it is. Okay, it'll say, oh, it's class MLE, and you can say is fit an MLE object, and that will say true. Okay, if you give it two arguments. So with S3, we were able to just turn any kind of object into a S3 object just by saying class of this thing is now something else, right? So I just took that vector of NAs and I said the class of this thing is now TTT, and R was like, okay, sounds good. With S4, you can't do that anymore. You have to create a representation of a class using this function setClass, and then you create new objects of that class using new. Okay, and then we got some documentation on this. So when you create an S4 class, it's going to have at least three things. It's got a name, so class. When you create a thing, you're going to say this is a class TTT or a class, whatever else. That's the name of the class, and then you give it a bunch of slots. Okay, and so slots are going to define what kind of information is held in this class. So if we wanted to create a class for person, a person class, we can say we're going to keep track of the name and the age of the person. The name will be a character value, the age will be a numeric value. Okay, and if you want something, you can write any, and that doesn't restrict the input type to character or numeric or whatever else you might want it. Okay, and if it's going to inherit properties from something, then you say it contains. So for example, we're going to create a person class with the field names name and age, and then we're going to create an employee class which inherits from person. Okay, and the employee class will take on the same values as person, but it adds an additional slot, boss. Okay, and we create new objects, or create objects using new with the name of the class. So for example, I'm going to create set class person. The slots are name, character, age, numeric. Over here, I'm going to create a new class called employee. The slots in this case will have boss as a person. Okay, and the employee thing itself contains all of the slots from person. And so we can define Alice as a new person. Okay, we're going to say new person, and the values that we want to store in the slots will be the name Alice and the age 40. John is going to be a new person. The employee, is a new class, is a new object of class employee. The name is John. His age is 20. Okay, and there is a slot for a boss, and the boss thing itself has to be a person object. So we have to put in Alice. Okay, or we put in someone else who's a person object. You can't just put in the name Joe or something like that, because Joe is not of class person. For when we say the boss is of class person, we have to give it a person object. So this would work here. So let me run all of this. So here I'm defining set class person, set class employee. We'll define Alice, and we'll define John. Okay. And then so I can ask, what is Alice? And it will say it's an object of class person. The slot is name, and the structure, and slot for name is Alice, and the slot for age is 40. If I ask str of Alice, it will say formal class person with two slots, name and age. Okay, and then if you want to pull any of these things out from the object, okay, you would use the @ sign. So you say Alice @ name. That's the character vector Alice, or Alice @ age, and that works out. Okay, if I tried to use $, which is often what we're kind of used to for pulling things out, it's going to say the $sign operator is not defined for this. Okay, so when you're using S4 things, you're using the @ sign. And often RStudio is smart enough to recognize like, oh, I see these 2 slots in here. Okay, and then John, we can pull out the name John, or we can pull out the boss, and we see that boss is actually the object Alice. Okay. Okay, if an S4 object contains an S3 class or a base type, it's going to have a special .data slot, which contains the underlying base type or S3 object. So you can put in the contains under the contains, like it's trying to inherit from numeric or something. Okay, you can it will have this special .data slot. Okay, so over here we're going to create a new class called ranged numeric. Okay, and here I'm going to create a new object, ranged numeric. So ranged numeric, if we look at it, it says it contains numeric. So contains, again, is the way it inherits properties, right? So earlier we used contains to say that John is an employee and it's inheriting properties from person. This time we can say, it's going to contain something, and we're not giving it an S4 thing, we're giving it a base type, numeric thing here. Okay, and then the slots that we're keeping track of are numeric and min and max. Okay, and so if I look at my object Rn, okay, it says an object of class range numeric. There are 2 slots, Rn $min, whoops, not $, sorry, @min. See, I still make these mistakes, and @max. These are the values in the slots, but then if I pull up the @, we also see this .data, okay, indicating the information that's stored in the part that it has inherited from. Okay, and so we're giving all of these things when we don't give it into the actual slot. Okay. It says R is an interactive programming language, so it's possible to create new classes or redefine existing classes at any time. This can be a problem when you're interactively experimenting with S4. If you modify a class, make sure you also recreate any objects of that class, otherwise you'll end up with invalid objects. So let me just recall that we have Alice from earlier. So if I say structure Alice, this is what we had. Let me, if I redefine the class person, so person I'm redefining to say it's going to have a name, an age, and a city associated with a person. Now when I try to pull up Alice, it's going to say that it's going to return an error. It's going to say there's no slot of name city for this person Alice, indicating that Alice is no longer a valid object here because I modified what the class person should be. Okay, so S4 is much more strict in this sense, in that it's going to return errors if the objects that you have aren't properly defined. So to fix this, I just have to go back and either give Alice a city, or I have to remove city from the definition of what a person is. Is this all okay? Yes?
Is there a specific structure for Alice, or can you still be extracting information in this?
So you can still, so the information in Alice, I think, is still there. Okay, so that's still there. It's just if we ever tried to do anything with Alice, it's going to say this is not a valid object because according to my definition of what a person is, a person also has a city associated with the person. And because Alice doesn't have a city associated with a person, according to our definition of what a person object is, Alice is no longer a valid person object. So, when you're, and then if you tried to create a new person and you didn't give it city, it would complain also. It would say like you're trying to here, let me just create Bob, Okay, and Bob is going to be a new person, and we would want to give it name is Bob and age will be 20. Okay. Oh, and but again, oh, I'm sorry. It just I guess it puts in a blank thing for city. Okay, I thought it would complain. Okay, and then we could, I guess, modify Bob in place later. We can say Bob's city is going to be LA. So we got this. Okay, so I guess it'll work here. But because Alice hasn't given anything, I wonder if I could just do Alice $city or @city, and we can give her NYC, and then Alice is now valid. Okay. All right. Okay, we can create new methods and generics in S4. So in S4, you turn a function, an existing function, by saying we're gonna set it to be a generic. Okay, and this now tells R, like, when you use this function, check to see if there's an associated class with the object that the function is running on. Okay, and if there is one, use the appropriate method. Okay, so we say set generic, and then we say, okay, we're gonna set a generic for the function union, and then what we want to do is we're going to, so union basically takes two vectors and it says like, and it puts them together, right? It just says like, okay, this is all of this stuff put together. And so here we're going to say, we're going to create a new method of union, and we're going to call it set method for union, and you're going to use this method if the X is of class data frame and Y is of class data frame. And then the function that is going to run is this thing, which just R binds the things and does a unique. Okay. And now this thing will run. Union will now run when you give it data frames, because set generic will, when you run the union function, set generic will look at what you've given it. It'll say, ah, you've given me data frames, so now I know I'm supposed to use this method for union. Okay. So it's no longer union.dataframe or something like that. It's with S4 we say set generic to tell it, don't just run the function anymore under union, but see if certain classes apply, and if so, run the special function for that, run the method for that function, for that class. Okay. If you want to create a new generic from scratch, you create something called standard generic, and you say this is standard generic, and this is the function, okay? And this is all you do. This is kind of like in S3 you say use method, right? You'd say like, oh, I want to print. If we look up print, it'll say like use method print, and it figures it out that way. Yes, question?
Can you explain what generic is?
What a generic is? So a generic is a function that has methods associated with it. Okay, so usually when you write a function, it's probably just one function, and it's only going to accept a certain thing, right? If you're writing a function to work on numeric vectors, it's only going to work on numeric vectors. But you might have something like the function print, where it works one way for numerical vectors, it works another way for factors, it works another way for objects of different types. Okay, and so in order to say the same print function, okay, rather than trying to make the print function itself super complicated and say like, if, you know, when you say print x, and you're not going to put like 1,000 lines of code saying if x is factor, do this, if x is numeric, do this. Instead, you say print is a generic using, and it's an S3 generic, so it's going to use method, and what it does is it looks up print, or it runs print, and then it says, oh, what kind of class is this object? Oh, this class is a factor. Now I'm going to run the factor method for print.factor. Okay, same thing here. Here I've got a new generic function called myGeneric, and myGeneric is going to be a function that executes when it gives me well, whenever I call myGeneric, I'm going to look for the method specific for this class. So I could have a myGeneric for the MLE class. I could have a myGeneric for the I don't know, some other person class of object. So whatever class it has, it's going to dispatch the correct method associated with that class rather than using one function for everything. Okay, is that all right? This concept of generic functions versus methods. So that as far as object-oriented systems go, R is pretty unique in that way because the methods are associated with functions, meaning you're going to have generic functions, and then the function will look up which method it should use. Yes?
Why are you calling standard generic? Like, that's just saying use whatever method is.
Yes, so standard generic is basically the S4 version of use method. So if you looked up print, it's going to say use method print. Okay, so but because this is now for S4, it's the same thing as having standard generic print or standard generic something. Okay, we're setting it up that way. Okay, so that's S4. And now we have reference classes. Okay, reference classes are the newest object-oriented system in R. And this is very different from S3 and S4 because here, for reference class, methods belong to the objects, not the functions. Okay, and this is a little bit more similar to the way object-oriented stuff is set up in Python or Java or other languages. And reference class objects are mutable, okay, meaning that so normally when you create something in R, it creates a copy of it. In reference classes, it doesn't. It creates a kind of like a reference to that thing. Okay, and they're implemented. They are special S4 classes. Okay, so if you look at the internals of a reference class, it's an S4 object inside. Not inside. It wraps around an environment. Okay, so a reference class is kind of set up as an environment, and that's how it maintains its mutability, because the values exist in this environment that's specific to this reference class object that you've created. Okay, so it says reference classes are best used for describing stateful objects, meaning objects that change over time. So we're going to create a simple class to model a bank account. Okay, and so to do this, you're going to use the function setReferenceClass, and the only thing you need to give it is a name. Okay, that's the only thing that's required. And then to create a new one, you use the new. Okay, and so in this case, we can create a new thing, account, and here it's going to create a reference class of account. And I can create a new account just by saying account, because this is now calling setReferenceClass and $new. So if I run account $new, it'll say reference class object of class account created here. Okay. So here we can have fields in a reference class, similar to slots, but to distinguish that this is a reference class, we call them fields. And so the only thing that we're keeping track of for our count is going to be the balance. Okay, so the setReference class will have a balance, and that's going to take on a numeric value. Okay, and so here we're going to create a new account A, and we say account $new, and we say balance is equal to 100. And we say, what's a $balance? So for a reference class, you use $ notation, not the @ sign. You say a $balance, A says 100. You can modify that balance. You say a $balance is 200 now. Okay, and now that balance is 200. So far this seems pretty straightforward. Okay, this is where things behave differently than what we're accustomed to. So here I'm going to say B, we're going to take A and we're going to store it in B. Okay, so earlier I changed the balance in A to 200. So now I'm going to say, okay, A we're going to also store in B, and we say, what's the balance on B? 200. I'm going to modify the balance in A to 0, and if I say, okay, what's the balance in B? It is now 0. Okay, so this is very different from what we're accustomed to, right? So, because normally if I just take a plain old thing and let me clear out my workspace here. If I say, you know, A is going to take on the value 200, and we're going to copy. So here it's going to create a copy, and here I can say, okay, A is now 0. A is 0, but B is still 200. Okay, with a reference class, it doesn't work that way. Okay, so here I've got the balance is now 200. A is the balance, and then if I just say B is now A, when we modify the balance in A, B is also affected. Okay, because they're referencing the same environment. Okay, so in order to handle this, there is a method called copy. Okay, so here right now, if I look at the balance in A, the balance in A is 0. We can say C is going to be a copy of A. Okay, and so this creates a separate thing for A and C. So we're going to take the copy of that, okay, and we can say, okay, what's the balance in C? The balance in C is 0. We can take the balance in A and now make it, what do we say? We're going to make it 100. So A $ balance is now 100, but C $ balance is still 0, okay? Because here we've created a copy rather than using the direct thing where we said, you know, A was going to be over here. Here they're pointing to the same thing. Here we have a copy. So this is reference classes. They're very different. Okay, so again, objects aren't very useful without some kind of behavior or some kind of methods associated with it. So with reference class, you modify its fields in place. Okay, and so to do this, you would create a list of methods. Okay, and the methods will have functions. Okay, the methods are themselves functions. And notice here we're using the super assignment. Okay, because what we want is we want the value changed, the value that we're modifying through this function not to just disappear inside here, but we want it to actually modify the balance that's up here. Okay, because these are inside there's a parent environment to this function, and that parent environment is the reference class object, and we want to change the values in the object itself. And so that's why we're using super assignment. The super assignment here does not affect anything in the global environment, okay? Because generally we want to avoid super assignment from affecting things in the global environment. This super assignment just allows you to change the values from inside the function to the values inside the reference class object. So here we are defining a reference class with a name account. So this is the class. The class is account. It keeps track of a balance, okay? And we're giving it two functions for the methods. The first function is called withdraw, and all it does is it takes the balance and it's going to subtract x. So you're going to say withdraw is a function of x, it's take the balance, subtract x, and update the balance inside the fields. For deposit x, you're going to take the balance, add x, and update the balance inside the fields. And so you need super assignment here.
So does super assignment changes values
Correct. Correct. So the reference class, it's an S4 thing wrapped around an environment. So inside the reference class is basically in this reference class there's not a whole lot. There's balance, and then now we're going to add two functions, withdraw and deposit. Okay, so you can think of it as inside its own little enclosed environment here, where there's the balance object, a withdraw function, and a deposit function. Okay, and so what we want to do is we want to, if we run the withdraw function, it would create an execution environment where the parent environment of that thing is the environment that has the balance. Okay, and so we don't want the values in the execution environment there to disappear. We want it to update the balance that exists in this kind of this environment created by the reference class, which is not the global environment. So that's why we're using super assignment here. Is this okay? All right, and then so here I'm going to create a new balance. All right, so let me just kind of demonstrate this. So here we're going to define our reference class this way, with the methods associated with the class itself. And so here I'm going to create a new account. So A is a reference class of class account, and it has one field, and that field is balance, right? So we can say, you know, it's the structure of A, and it's got this, and it says, okay, and then so now we can run the method deposit. We're going to say A $deposit 100, okay, yeah, not S, A, okay, and so now if we ask what's the balance in A, it's now 200, okay, and so notice this is different, so from other things in R, right? Because normally if you wanted to update the balance in A, you'd have to do like A balance to be something like, we're going to take the current value of balance and add 200 to it or something like that. So I mean, this would still work, okay? But you have methods and now we can ask what's the balance. So we have methods, and so this, I mean, anytime you have mutable objects and functions that change those things, it's not always apparent to see what change has happened, right? Okay, is that all right? Okay, and so we can also have other reference class objects inherit things from things like that. So here we're going to create a special kind of account called a no overdraft account. And so the no overdraft account is going to inherit from account, or we're going to say contains account. And here, the only thing here is that for the methods, we're going to give it its own withdraw function. And the withdraw function here will just do a check to make sure that the amount you're withdrawing is not greater than your balance. And if it is, it's going to give you an error that says not enough money. Otherwise, it will deduct the amount X from balance. Okay, so this no overdraft is inheriting everything from account. So that means it's going to inherit the deposit method and inherit the balance field. It also inherits the withdraw method, but because we are giving it a new withdraw method, this one will kind of hide the other withdraw method. So so here we're going to create account John no overdraft as a new no overdraft object. We're going to give it $100. Okay, we can run the deposit method. Okay, even though we didn't define deposit in here in this thing of methods, because it has inherited everything from account, this deposit function works, or this deposit method works. And we can see that the balance is now 150. And then if I try to withdraw 200 from it, it's going to give us an error that says not enough money. You can oh, this didn't format the way I expected. Oh, I know. Okay. The all of the classes eventually reference from this thing called environment reference class, which gives it useful methods like copy and field and export, show, call super, these other methods that kind of apply to all reference classes. Okay. You can recognize a reference class object because it is an S4 thing, but it will also say, you say, is it reference class? Okay. Or you can use prior, and the O type will say it's a reference class. As far as method dispatch goes, it's very simple because in reference classes, the methods are associated with the class. They're not associated with functions. So if you ask for a certain function, it's going, or ask for a certain method, it's going to look for the method in that class itself. If it doesn't find it, it'll go to the parent class and look for the method there. So that's why when we said, run deposit on the new overdraft thing, it didn't find deposit in the list of methods there, so it went to the parent thing, which was the account class, and it found the deposit function or deposit method in the account class. Whereas when we said do the withdrawal, it first looks inside the no overdraft class, and it finds the withdraw function there, and it gives an error. If you wanted to run the withdraw method from the parent class, you can do that. Okay, so remember, so we have, whoops, did I not create, oh, I didn't run all of this code. So we're going to define overdraft and create. Okay, so here I've got account John, and when I say withdraw, it's using the withdraw method that's defined inside the no overdraft class. Okay, if I wanted to use the withdraw from the parent thing, I can say account John $, and you'll notice that I've got withdraw and I've got withdraw like almost hashtag account. Okay, and so this means it's going to use the withdraw method from the account reference class. Okay, and so here I can say I'm going to withdraw 200, and it's not going to give an error, and we can say, what's the balance in account John, and we're at -50 now. Okay, so reference classes work that way. All right, is that okay? Before I talk about the midterm exam, are there any questions? Okay, so the midterm will be 1 week from today, so week 5 Friday, and that will be right here in class. It'll be 45 minutes. It'll be handwritten. Okay, and for most of the problems, I will show you a few lines of code and ask you to write what R will output. Okay, so I'm thinking it will be pretty straightforward. I'm gonna have to, the hardest part for me is figuring out the appropriate length of the exam. I know you guys only have 45 minutes, so I figure I have to write something that I can finish in like 10 or 15 minutes, okay? And that should, I'm hoping, would be the right length for you guys, which means some of you will finish in 10 or 15 minutes, and then others of you will take the full amount of time, which is totally fine with 45 minutes, okay? So, here's an example. I can ask, what will our output? We've got x is 0 for I in 1 through 3. Take x plus 3, and print x. Okay, so what's this going to output? So it will produce 3 lines. One, then, it'll produce, it'll take 3, 6, and then 9. Okay, so it'll start off with 0. Okay, right? X is 0. I'm sorry. Yeah. So 3, 6, 9. Yes.
Are we going to have multiple choice, or all of them are showy word?
Yeah, it's all going to be handwritten. Okay, so it's not going to be multiple choice. All right.
Even the hashtag?
No, you don't have to write this, okay? But I would expect you to write 369, okay? If they were written 3, comma 6, comma 9, or 3 space 6 space 9, I don't know. Well, that's technically not correct. I don't know. You know, the exam is going to be out of 100 points, right? And I don't know how much this thing would be worth, but you'll probably lose at least 1 point if you don't have the correct output, right? Okay. Sometimes I might put code that will result in an error, okay? And you'll need to say it will result in an error. So for example, if I say x is a and I do y is x plus 3, okay? It will say error, okay? Now you don't need to say exactly what the error message will be, but you do need to say it will produce an error, okay? So I don't expect you guys to memorize all of these things. Non-numeric argument to binary operator, I don't expect that. But I do expect you to say, oh, this is going to produce an error here. Huh? Oh, error versus warning? Yeah, you should note that, okay? All right. See you guys Monday.